Let's talk about coal. It's the rock that literally powers nations, the engine of industry. But what if I told you that a huge chunk of the coal being mined isn't really coal at all? Today, we're going to dig into a massive hidden problem deep inside India's coal seams and the really clever science that's being used to solve it. And this number, this is what it's all about. 40%. On average, a staggering 40% of the raw coal that comes out of the ground in India isn't actually fuel. Nope, it's unburnable rock, shale, and other mineral waste just mixed right in. Think about it like this. Imagine buying a big bag of expensive coffee beans, only to get home and find out that almost half of it is just pebbles. That's the problem we're dealing with. And to put that into perspective, let's look at what the industry calls ash content. That's just the fancy term for all that leftover waste. So, Indian coal clocks in at 30 to 45% ash. Now, compare that to international coal, which usually sits somewhere between 5 and 15%. I mean, that's not just a small difference, right? That's a massive gap that completely changes the game for how you can even use this stuff. So, why should we care about all this ash? Well, because this isn't just some number on a spreadsheet. It has huge, expensive, and frankly, polluting consequences in the real world. Let's break down what actually happens when you try to burn this, let's call it dirty coal. Well, first off, you're literally paying to haul millions of tons of useless rock across the country. That's a huge waste of money and energy right there. Second, all that rock gets in the way of the actual coal, which means you get way less heat out of it. Third, this stuff is abrasive. It's like sandpaper. It just grinds away at and damages really expensive equipment like boilers and furnaces. And finally, when you burn it, that ash has to go somewhere, and it goes up into the air as fly ash, a major pollutant. It's a chain reaction of problems. Okay, so before you can even think about fixing a problem this big, you have to understand it, right? You've got to know exactly what you're dealing with. And in the world of coal, that means figuring out what's really inside a lump of it. This is where a key piece of science comes into play, a way to analyze the good, the bad, and the ugly parts of coal. It's called Proximate Analysis. Sounds kind of technical, but think of it like a standard blood test for coal. It's a simple, universal lab test that tells you the 4 key ingredients that make up any piece of coal and determine its quality. It's the absolute first step in the whole process of cleaning coal, or what the pros call beneficiation. So let's meet the players. First up, we have fixed carbon. This is our hero. This is the good stuff, the pure fuel that actually burns and creates all the heat and energy we want. With fixed carbon, it's simple. The more, the better. And of course, every hero needs a villain. And in our story, that is definitely ash. This is all that non-burnable junk we've been talking about. The rock, the clay, the shale. It does nothing but add weight, it produces zero energy, it creates pollution, and it wrecks machines. The entire goal of cleaning coal is to kick this villain out. And then we have the sidekick, volatile matter. These are basically gases that are trapped inside the coal. Now, they're useful. They help the coal catch fire really easily. They kind of get the party started. But they're not the main source of heat. Fixed carbon is the one that keeps the fire going all night long. Okay, so we've identified the problem and we know our villain is ash. So how in the world do you get it out? You might be picturing some super complex chemical process, but the entire multi-billion-dollar industry of coal cleaning is actually built on one incredibly simple scientific principle. And here it is, get ready for it. Coal is light and rock is heavy. That's it. Seriously, the density of coal is much lower than the density of the rock and shale mixed in with it. Every single technology for cleaning coal, from the simplest little machine to the most advanced ones, is just a clever way to take advantage of that one basic difference in weight. So, working from that one simple principle, engineers have come up with 2 main families of solutions to separate the good stuff from the bad. You can do it using dry methods without any water, or you can use wet methods. Let's take a look at one of each. So a classic dry method is the rotary breaker, and this thing is just genius. Picture a giant rotating metal drum, like a huge laundry dryer, but with holes in it. You feed the big, mixed-up lumps of raw material in one end. Now here's the clever part. Coal is pretty brittle, so as it tumbles around, it shatters into smaller pieces and falls right through the holes. But the rock, it's much tougher. It just gets carried along for the ride and gets spit out at the other end. Simple, but so effective. All right, now for a super high-tech wet method, the dense medium cyclone. This is where things get really cool. First, you create a kind of heavy liquid by mixing water with a fine magnetic powder called magnetite. You get the density just right, heavier than coal, but lighter than rock. Then you pump this whole slurry into a cone-shaped cyclone at really high speeds. The intense spinning motion, the centrifugal force, flings the heavy rock to the outside wall, where it spirals down and out the bottom. And the lighter, clean coal, it gets pulled into a vortex in the middle and spirals right up and out the top. It's an incredibly efficient way to separate the two. So how do you choose? If you put these two methods head to head, it's really all about trade-offs. Dry methods obviously use no water, which is a huge plus in dry areas, and they're cheaper to run, but they're not quite as efficient. Wet methods, on the other hand, are way more efficient. They produce a much cleaner final product, especially with the really fine coal particles. The big downside? They use a ton of water, and you have to deal with all the leftover slurry. So after all of this, all the breaking and tumbling and spinning, we're left with cleaner coal. By getting rid of the villain, all that ash, we have fundamentally changed the fuel itself, and in doing so, we've solved the very problems we started with. And this is why it's such a big deal. When you wash the coal, its heating value can jump by 30, 40, even 50%. You save a fortune in transportation because you're not shipping useless rock anymore. You dramatically cut down on fly ash pollution. Your expensive equipment lasts way longer without all that rock grinding away at it. And for some industries, like steelmaking, which needs super pure low-ash coal, well, this whole process isn't just helpful, it's absolutely essential. And this leaves us with a much bigger thought to chew on. The global conversation, and rightly so, is all about moving to cleaner, renewable energy. But in that huge transition, what's the role for technologies like these? The ones that don't replace fossil fuels overnight, but instead make them significantly more efficient and less polluting, buying us crucial time and cleaning up a huge part of the energy system we rely on today. It's a really important question to think about.